store and trust our data? That's probably one of the most important questions of our time. And it's not just some techie debate, it's really a philosophical one. We are literally at a fork in the road, choosing the foundation for our entire digital world. On one path, you've got the systems that built the internet we use every day, systems that are fast, efficient, and, well, controlled. On the other path, a totally radical new way of thinking about trust, one built on transparency and decentralization. So let's go down these paths and see where they take us.
Okay, to really get why this choice matters so much, let's just start with a hard number, $2.17 billion. According to security experts, that's how much was stolen from crypto services in 2023 alone. Now, this isn't just about a few hacks. It's a massive, glaring spotlight on just how fragile our digital world can be, and the incredibly high stakes of getting this whole architecture of trust thing wrong.
So today, we're going to break down the three big contenders fighting to be the backbone of our digital lives. First up, you've got traditional databases. They're the bedrock of modern computing. Second, there's blockchain, the revolutionary, decentralized force. And third, we've got distributed file systems, kind of the unsung hero of big data in the cloud.
All right, here's the game plan for how we're going to make sense of all this. We'll kick things off with the core data dilemma. Then we'll define these three very different architectures of trust. After that, we'll dive into the ultimate trade-offs because, spoiler alert, no system is perfect. And finally, we'll look at what's probably going to happen, a hybrid future, where these things don't compete, they actually work together.
Okay, first things first. Before we can have a real conversation about this, we absolutely need to get on the same page about how each of these systems actually works. What makes them tick, and what problem were they fundamentally designed to solve in the first place. Let's start with the one that runs pretty much the whole world today, the traditional database. This is your classic client-server setup. There's a central authority, a database admin, who is in charge of everything. All the data is organized super neatly into tables with rows and columns. It's ridiculously fast and efficient for things like your bank account balance or a company's customer list.
And this analogy really nails it. Think of a database like a big central library. There is one head librarian, and they hold the master catalog. If you want to check out a book, add a new one, whatever, you have to go through them. It's efficient, for sure. It's controlled. But it's also a single point of failure, right? If the librarian gets sick or, the library burns down, the entire system just stops working.
And then you have blockchain, which just completely flips that whole idea on its head. Instead of one person in charge, you have a decentralized network. Thousands of people, all holding an identical copy of the same ledger. Transactions get bundled into these things called blocks, and each block is sealed with a unique digital fingerprint, a hash, that's mathematically tied to the one before it. This creates an unbreakable, unchangeable chain, and for a new block to get added, the whole network has to agree.
The analogy of a public notary book is just perfect here. Imagine that everyone in your town has a magical, identical copy of this book. If you want to add a new entry, you have to shout it out to everyone, and a majority of them have to agree to write it down in their copy. And once it's written down, it can never, ever be erased. The trust isn't in some person, the trust is baked right into the network itself.
And finally, let's talk about the powerhouse behind big data, the distributed file system, or DFS. Its whole purpose in life is simple. How do you manage enormous files? I'm talking terabytes of video or scientific data that are way too big for just one computer. Well, a DFS does it by breaking that file into smaller chunks and then spreading those chunks across a whole network of machines. The magic key here is a central server that acts like a table of contents, keeping a master map of exactly where every single piece is stored.
To really get this, just picture a giant, beautiful mosaic masterpiece. It's way too big for any one vault, so what do? You smash it into thousands of little pieces, and you store each piece in a different safe deposit box all across the city. The only way you could ever see the full picture again is by using that one single master map that tells you which piece is in which box. That map, that's your central index.
All right, so now we have our three systems defined, and this brings us to what is maybe the most important part of this whole explainer, understanding that when you choose one of these systems, you are making a critical set of trade-offs. There's just no free lunch here. See, at the very heart of this whole debate is this fundamental conflict. Centralized systems, like our traditional database, and most DFS setups, they're built to optimize for speed and for control. Decentralized systems, like blockchain, they're built to optimize for trust and transparency without needing a middleman. You just cannot have it all at the same time.
So, let's break this down. It's all laid out right here in this table. Look at authority. Databases and DFS, centralized, one boss. Blockchain, decentralized, no boss. Okay, what about mutability? Can you change the data? In a database or a DFS, yeah, totally. Data can be changed or deleted pretty easily. But on a blockchain, it is effectively immutable. Once it's in, it's there for good. Now, performance. This is a big one. Databases and DFS are built for speed, for high throughput. Blockchain, because it needs that network-wide agreement for everything, is just inherently slower. And finally, the security model. Databases rely on access controls. Who gets the password? Blockchain relies on cryptography and consensus. Can the whole network verify that this is true?
This whole performance issue with blockchain is so fundamental, it actually has a name: the scalability trilemma. It's a concept that was famously laid out by Ethereum's founder Vitalik Buterin. And what it says is that you are basically forced to choose between three core properties.
So the trilemma gives you three things you want: decentralization, security, and scalability, which is just a fancy word for transaction speed. The theory is you can pick any two. That's it. Any blockchain design can only really optimize for two of those three things. You want insane scalability? You might have to give up some decentralization and use fewer, more powerful computers. You want maximum security and decentralization? Well, then you're probably going to have to sacrifice speed. It's not just a tech challenge. It's like a fundamental law of these systems.
And this chart, wow, this really just puts that challenge in perspective. Bitcoin can process maybe 7 transactions a second. Ethereum's a bit better, but we're still talking low double digits. But a traditional, centralized system like Visa, it handles tens of thousands of transactions every single second. This really visualizes the huge performance gap that blockchain has to figure out if it's going to be used for things like global payments or social media. So, if no single system is perfect, then what does the future actually look like? Well, that brings us to the most pragmatic and, frankly, the most likely outcome: a hybrid approach. This isn't about one technology winning, it's about using the right tool for the right job. We're already starting to see these really sophisticated systems that intelligently combine the strengths of each architecture. The whole idea is to stop thinking about this as some kind of battle to the death and start thinking about it as building a better, more versatile toolkit. It's about picking and choosing the best features from each system to build something new.
So what does that actually look like in the real world? Let's walk through an example. Imagine a system for verifying, say, university diplomas. You would never store a giant PDF of a diploma on a blockchain. It would be way too slow and crazy expensive. Instead, you'd store that file on a DFS. Then, you take a unique digital fingerprint, the hash of that diploma, and you record that on a blockchain. That gives you an unchangeable, time-stamped proof that the diploma is real. And in the meantime, you'd use a super fast, traditional database to handle all the everyday stuff like student logins or searching for courses. See, each one does what it's best at.
So, when it all comes down to it, here's the simple framework. If what you need more than anything is lightning-fast speed and total control over your data, you're going to use a traditional database. If you're dealing with massive amounts of data and you need it to be resilient, a DFS is your tool. And if your absolute non-negotiable goal is trust and transparency without a central party calling the shots, then you need a blockchain. It's that simple. Ultimately, that brings us to our conclusion. The whole conversation is moving beyond blockchain versus databases. The real revolution here isn't about one technology completely replacing another. It's about having a fundamentally new set of tools to solve problems in ways we just couldn't before. For the first time ever, we can actually sit down and deliberately design systems based on the specific kind of trust they require.
And that leaves us with one final question for you to think about. Look at your own digital life, your social media, your banking, your health records, all your photos. What parts of that would you feel comfortable handing over to a decentralized, trustless system if it meant you had more transparency and ownership? And what parts are just so critical that you would never, ever want to give up the speed and control that a centralized authority gives you? The answer to that question really tells us everything about the future we're all building, one system at a time.